Have you ever gazed into the night sky and wondered how our solar system came into existence? It's a question that has captivated the human mind for millennia. Isn't it fascinating to think that we are but tiny specks in the grand tapestry of the universe? It's this very intrigue that has driven us to explore the mysteries of space. Our ceaseless curiosity has led us to unravel the secrets of the cosmos, to delve into the enigmatic depths of the celestial world. And today we're going to embark on a journey that takes us back billions of years to the very beginning of our solar system. We'll explore the cosmic phenomena that led to the formation of our sun and its orbiting planets. From the swirling cosmic dust to the fiery birth of the sun, we'll unfold the story of our cosmic neighborhood. Come along on a journey through time and space to discover the birth of our cosmic neighborhood. Our story begins about 13.8 billion years ago, with a monumental event known as the Big Bang. This colossal explosion is not just the stuff of legend, but the very catalyst of our universe. The Big Bang wasn't an explosion in space, but an explosion of space itself, creating the stage for everything we know and see today. Picture this. In the beginning, there was nothing. Then in an instant, there was everything. The universe in its infancy was a hot, dense point nearly infinitely small. Then it expanded faster than the speed of light, growing from microscopic to cosmic in size in a fraction of a millisecond. This rapid expansion spread out the energy and matter within, giving birth to time, space, and the laws of physics as we understand them. As the universe expanded and cooled, matter began to clump together under the influence of gravity. This coalescing matter eventually formed galaxies, each a whirl of stars, dust, and gas bound together in a cosmic dance. But galaxies were not the end of the story. Within these galaxies, the stage was set for the birth of stars and their accompanying planets. Now, let's zoom in on one particular galaxy, our own Milky Way. Here, around 9 billion years after the Big Bang, a cloud of gas and dust began to collapse under its own gravity. This cloud, known as a nebula, was the remnants of previous generations of stars, a cosmic recycling bin, if you will, filled with the raw materials needed to build a new star system. This nebula swirled and condensed, the pressure and temperature at its core rising. The heart of the nebula ignited, giving birth to our sun. Around this nascent star, the leftover dust and gas began to form a flat, rotating disk. From these cosmic dust and gas clouds, the stage was set for the birth of our solar system. Now imagine a cloud of dust and gas, spinning and collapsing under its own gravity. This was the scene about 4.5 billion years ago in a region of the Milky Way galaxy. Within this swirling, chaotic cloud, a process was underway, the birth of a star, our sun. As the cloud collapsed, it began to spin faster, with the material in the cloud forming a flattened disk with a hot, dense central region. This central region would eventually become the sun, but it wasn't a star just yet. The pressure in the core of this embryonic sun reached staggering levels. Simultaneously, the temperature began to rise dramatically, reaching millions of degrees. This intense heat and pressure set the stage for a process that would light up this dense ball of gas, turning it into a shining star. This process was nuclear fusion. The enormous pressure and heat in the sun's core caused hydrogen atoms to come together, to fuse. This fusion of hydrogen created a heavier element, helium. But this wasn't just a simple matter of atomic addition. During the fusion process, a tiny amount of matter was converted into energy, as dictated by Einstein's famous equation, E equals mc squared. This energy, produced in the core, began to radiate outward, fighting against the inward pull of gravity. This tug of war between gravity pulling inward and energy pushing outward created a delicate balance, a state known as hydrostatic equilibrium. The sun was now a full-fledged star, a gigantic glowing sphere of gas powered by nuclear fusion in its core. The sun continued to grow, gathering up about 99% of all the matter in that original cloud of gas and dust. The remaining 1% would eventually form the planets, asteroids, and comets in our solar system. And so the heart of our solar system, our sun, was born. It's a story of unimaginable pressure and heat, of gravity and fusion, of dust and gas transformed into a star that has shone brightly for billions of years. And it's still shining today, the source of light and life on our planet Earth. With the sun in place, the rest of the material in the cloud began to form the planets. This process, known as accretion, was an epic cosmic event of dust and gas clumping together, gradually forming larger and larger bodies. Envision a cosmic dance, where countless particles of dust and gas left over from the formation of the sun begin to gravitate towards each other. These particles, drawn together by the fundamental force of gravity, start to collide and stick together, forming larger clumps of matter. This is the very beginning of the process known as accretion. As these clumps grow in size, their gravitational pull also increases, attracting even more dust and gas. This is a snowball effect. The bigger they get, the more material they attract and the faster they grow. Over time, these clumps become so massive that they start to take on a spherical shape due to gravity. But it's not just about growing in size. These growing bodies, now called planetesimals, also need to survive the harsh environment of the early solar system, filled with intense heat and violent collisions. The planetesimals that survive these tough conditions continue to grow, becoming protoplanets. As these protoplanets grow and evolve, they start to undergo differentiation, a process where denser materials sink towards the center and lighter materials rise to the surface. This creates a layered structure similar to what we see in the Earth today, with a dense core, a mantle, and a crust. At the end of this long, brutal, and chaotic process, we have the birth of planets. Bodies so massive and complex, with their own unique compositions, atmospheres, and environments. Some of these planets, like Earth, even have the right conditions to support life. Keep in mind that this process didn't happen overnight. It took millions, even billions of years for these planets to form and evolve into the celestial bodies we know today. It's a testament to the grand scale and majesty of the universe, where even the formation of something as familiar as our own planet is a cosmic event of epic proportions. This process gave birth to the planets, and thus our solar system was formed. Fast forward to today, and we find ourselves in a solar system with a diverse range of planets. We begin our journey close to the Sun, where the 4 terrestrial or rocky planets reside. First up, we have Mercury, the smallest planet, a scorched world with a surface crisscrossed by craters and wrinkles. Next, we have Venus, our nearest neighbor, shrouded in a thick, toxic atmosphere that traps in heat, making it the hottest planet in our solar system. Then there's our own planet, Earth, the only known celestial body to support life, with its perfect balance of land, water, and atmosphere. Finally, among the rocky planets, we have Mars, the red planet, known for its iron-rich soil and the largest volcano in the solar system, Olympus Mons. We then move to the gas giants, also known as the Jovian planets. Jupiter, the largest planet in our solar system, is famous for its great red spot, a storm that's been raging on for centuries. Saturn, with its iconic rings made of ice and rock, is not far behind in size. Beyond Saturn, we find Uranus, a planet with a unique tilt that causes it to spin on its side. And lastly, we have Neptune, the furthest planet from the Sun, known for its intense blue color and supersonic winds, the fastest in the solar system. But our solar system isn't just planets. We have the asteroid belt, a band of rocky debris between Mars and Jupiter. Then there's the Kuiper belt, home to a myriad of icy objects, including Pluto, once considered the 9th planet. These celestial bodies, each with their unique traits, make up the solar system we call home. Their formation and existence in the vast void of space is a testament to the cosmic forces that brought them into being, and the intricate dance of gravity that keeps them in their orbits, a spectacle of cosmic harmony that we're privileged to witness and explore. So, what have we learned about the formation of our solar system? We've taken a cosmic voyage beginning with the Big Bang, that incredible explosion that marked the start of not just our solar system, but the whole universe. We traced the path of cosmic dust, swirling and coalescing under the force of gravity, to form the heart of our solar system, the Sun. Once the Sun was born, its gravitational pull gathered the remaining dust and debris, creating protoplanets. Over billions of years, these protoplanets collided and merged, growing into the planets we know today. From the scorching Mercury to the icy Neptune, each planet is a testament to the power of nature and the passage of time. Our journey ends here, but the universe continues to evolve and expand, just as our understanding of it does. Next time you gaze at the night sky, remember the cosmic journey that led to the creation of our solar system. It truly is a marvel of the universe.